Okay, how we doing, Raheel? Hello, Raheel, can you hear me?
Yeah, I can hear you now.
Brilliant. Okay, good stuff. Raheel, I do apologize that I only managed to send through the other stuff on displacement reactions a bit later.
Oh, it's fine.
Manic and hectic, yeah. So I'm not expecting that you'd have had a chance to go through it. But when you do get a chance, please do go through it. There's answers attached. So
Okay.
you'll be able to mark that as well, yeah?
Yeah.
Yeah. Okay, cool. So let's just kick off then, and just to make sure that firstly, this idea on limiting reagents, because we'd done a question on it, but that was only just one question, and really just wanted to make sure that you are absolutely fine with it in all the different ways that you could probably be asked it or questions on it. So do you want to, when you're ready, do you want to start off with the first multiple choice question?
I've worked out the moles.
Yeah, good.
And then do our times. So if I've got 1 mole for the hydrogen.
Yeah.
So what I times that by 3, and then
To work out, okay, so so I'm just looking, so a formula for number of moles is the mass over the relative atomic mass, yes?
Yeah.
So if you times the moles by the molar mass, you would be getting, but remember the molar mass does not include the number at the front.
yeah, I've got 1 as the moles for hydrogen.
You've got one as the number, one as the moles for hydrogen. Oh, I
Yeah.
see, I see. So you're asking then, the next step is in, do you multiply it by the molar mass of hydrogen?
Like if you're working out the limiting reactant.
Yes, so okay. So firstly, the key thing is you always start with a ratio from the balanced equation. So I've got 1 mole to 3 moles producing 2 moles. So it's a 1 to 3 to 2 ratio.
Yeah.
Okay. And then you see which one doesn't meet up to the value of its ratio compared to everything else, in another way of expressing it. Yeah. So then you ask yourself, so you said here 2 grams of hydrogen, which gave you 1 mole. So if you have 1 mole of hydrogen, what have you done here to get from 3 to 1?
Divided by 3.
You've divided by 3. So everything should be divided by 3. So you should hope to have a third. And now your question is to ask yourself, do I have a third to meet this 1 mole of hydrogen?
Wait, so like, so if I've got 0.442, I've got 0.43 for
Then you've got to ask yourself 0.43. What is a third as a decimal?
0.3 recurring.
0.3 recurring. Now you help me address the question. Does this mean this is in short supply or it's in excess supply?
Is it in excess?
Correct, because I am saying I only need this to react with 1 more. But actually, hey, I've got more than that. So as long as you find the one that is in excess, automatically the other reactant becomes limiting.
So then do I just take that away from 3
And then
the excess mass?
Then you take out the excess mass away from not 3, from 3 grams, because it says here, what is the mass of the excess reactant? Yeah. So we know which one is the excess reactant, and the excess reactant is nitrogen. And do we know how many moles of nitrogen are going to react? If we know the number of moles, we can work out the mass, because the mass that will react will be given by the number of moles that are going to react multiplied by the molar mass of the nitrogen.
So isn't the mass already given?
Yeah, so the mass of nitrogen is given, but because it is in excess, what we mean by it being in excess is that not all of it will react.
Yeah.
Does that make sense, right? Because it is in excess. So the thing that is limiting, all of it is going to be used up. So what we're saying is when all the hydrogen has been used up, what mass of nitrogen will remain? That is what this column is for. What is the mass of the excess reactant? So the excess reactant is nitrogen. Are you following so far?
Oh, wait, the limiting reactant was hydrogen, wasn't it?
Correct. So this table is testing you on 2 things. The excess reactant is never the limiting because it's in excess.
Yeah.
In surplus. The limiting reagent. So from this stage, you should probably be thinking, right, the answer is probably going to be C or D. Why is it C or D? Because the hydrogen has been identified correctly as the limiting reactant.
Yeah.
So the question here in this column is saying, what mass of nitrogen will be left at the end of the reaction? Because there must be some mass because it is in excess.
So, oh no. I'm not sure.
Okay. If in doubt, let's break it down to a simpler analogy that might make sense. Okay, so imagine, I don't know, you are making some bangle, and to make one bangle, you need one elastic and 3 beads. And this gives you one bangle.
Yep.
Okay, now we say that we have, just to make it interesting, 8 beads, and we have 3 elastic bands. How many bangles will I make with this? In other words, which is limiting? Which one is limiting? The number of elastic bands or the number of beads? How do you respond to this one?
Is it the number of beads?
The number of beads, you're absolutely right, because I would be expecting to see 9 beads, wouldn't I? But I don't. So this is a limiting. So how many bangles at the most will I be able to create?
2.
2 bangles. You're absolutely spot on. I can only make 2 bangles. Yeah. And if I make 2 bangles, then the equation now would look like 3 elastic bands plus, oh, sorry, 2, sorry, I beg your pardon. 2 elastic bands plus 6 beads to give me 2 bangles.
Yeah.
Now the question is, how many beads will be left over if I had 8 beads to start off with? Well, the number
2.
of beads that are going to be left over is 8 minus 6. That's exactly what this question is drawing at.
So,
Yeah, go on.
but
So if we just break it down, almost using a similar line of thought.
But if the mass is 12, I thought that, oh no, the mass is, yeah, if the mass is 12, I thought you'd have to like take away the 2 from the hydrogen, because that's all that.
Oh, that's reacted. I see. Okay. Let's do it on another page here then. I'm just going to grab this very quickly, and then we'll take it to slightly fresher page. This is getting a bit crowded. All right. And we'll insert a new page, blank page after current. Okay. So let's just take it right from the top. So looking at the steps you've done and then see where the missing links are. So far, using this equation, N2 plus 3H2 gives 2NH3. We've established using this ratio 1 to 3 to 2, because you've already calculated the number of moles of hydrogen. So you said N, I'm just going to say H here. For H2, the number of moles of hydrogen we found by saying 2 divided by the molar mass of hydrogen, which is also 2 grams. So you found that as 1 mole. Yeah. And so we said, okay, if I have 1 mole of hydrogen, based off this ratio, to get from 3 to 1, I've divided by 3. So I'm also going to have to divide that by 3 to work out the number of moles of nitrogen that 1 mole of hydrogen will react. Yes, if they were all in equal amounts, the right amounts. So we know that 1 mole of H2 will react with 1/3 of a mole of N2. Yeah. Now then we say, okay, so 12 grams, how many moles does 12 grams actually represent? Is it a third mole of N2? Well, we're going to check that then, right? So then to check how many moles, we say again, using the same formula, mass over molar mass, but this time we're doing it for nitrogen. So the mass is 12 grams divided by 28. Okay, so 4 into 12 is 3, 4 into 28 is 7. So when you have 3/7, okay, so we have 3/7 of a mole. Now, we can work in terms, so there's a number of ways we're going to do this, and all of them are going to show you that there's a number of ways of doing it as long as you're working with the ratios. But let's look at the first method, and then you can choose which method is easier for you. So there we go, 3/7 of a mole. If I compare 3/7 of a mole, and I've only got a third mole, well, there's one thing I can ask myself. If I've got 3/7, and we know that this is bigger, 3/7 is bigger than a third. So we've established that N2, therefore, N2 is in excess.
Yeah.
So if I've got 3/7 of a mole of nitrogen, and only a third is going to be needed to react, how much more, how many moles of nitrogen will be left at the end? Let's ask ourselves that question. What would you do to work that out? How many moles of N2 will be left at the end?
3/7 minus a third.
Correct. 3/7 minus a third. And what's that going to give us? Okay, 21, 3, that's 9 minus 7. So I will have 2/21 left.
Yeah.
Now, these are the number of moles. These are the number of moles. How do we work out, if you know the number of moles, how do we work out mass? There's a formula here that says that to work out the mass is, and this will represent the mass that will be unreacted. The mass of N2, of nitrogen. Does that make sense? Because these are the number of moles that are left. Good. So this will be given by the number of moles times the molar mass of nitrogen, which is the number of moles is 2/21 multiplied by the molar mass of nitrogen is 28. Yeah, 28, which gives you 56/21. The answer should be 2 point something, not sure what that is. But without doing much, I can see that it definitely can't be 9, because 56 divided by 21 is definitely not 9. It's closer to 2.7 more than anything. Therefore, the answer would be C. Okay. What's the other way of thinking about the problem? The other way of thinking about the problem is think about purely in terms of mass, especially if you're given reacting masses. So what you could do is, can I scroll further down here? All right, we're just going to call this method 1, just to make life easy, and start on a new page. Method 1. Method 1. We're going to look at method 2 now. Okay, so just gonna grab this again. Oh, actually, no, gotta do this again. Just remember that I'd already taken a screenshot, so I did have it already. There we go. And insert page, blank page after current. Okay. Here's another way of looking at the problem. But again, ratios are very much at the heart of the solution. So the other way you can look at it, in terms of now ratios of moles, so these here were the ratios in terms of moles, isn't it? 1 to 3 to 2. You can also think about it in terms of ratio of masses. Why can you think about it in terms of ratio of masses? Well, this formula here, M/mR, what this is telling us, MR for any one particular substance is fixed, the molar mass. This tells us that N, bring in some maths here, is directly proportional to mass. The number of moles is directly proportional to the mass. And the constant of proportionality is 1/mR. that 1 over mr is the constant of proportionality. So if you remember learning proportionality in maths, you can write this then as 1 as well as k times m, where k is 1 over mr multiplied by the mass. Okay, so we know that n is directly proportional to mass. So instead of using the ratio of moles, I can also use the ratio of mass because these two things are directly proportional. So what is the ratio of masses? Well, if I write out, and I should only use the ratio of masses in the balanced equation, only always in the balanced equation. So N2 is 28 grams, okay? Now this here would be 2 times 3, which is 6, and this here would be, well, this is 14 plus 3, 17, 17 times 2, 34. So this is the ratio of masses. Okay, so we are using ratio of masses, not even using ratio of moles. Now, if we want to put what we've got in here, okay, so assuming we found what our limiting reactant is, and we know that our limiting reactant is the hydrogen, yeah, or even if, let's just imagine we're doing everything, we're going to find what the limiting reactant is. We don't know what it is. Let's just say that. Now we're going to use this. So the ratio here is 28 to 6, yes, between the nitrogen and the hydrogen. I'm not too worried right now about the ammonia part because it's these two reactants I want to gauge what is limiting. So I can ignore this for now, yeah? And so I have 2 grams of hydrogen, yes? And what did I do here to get from 6 to 2? Well, I divided by 3. So I'm going to have to divide this by 3 as well. Now, what is 28 divided by 3? I think it was that value that you found of 9.3, isn't it?
Yeah.
So I get 9.3 recurring. So in other words, what I'm saying is 2 grams of hydrogen need 9.33 grams of nitrogen based off this ratio. But hey, check it. I've got 12 grams of nitrogen. So in other words, this is going to react, but there's going to be some left over. So what will be left? Well, what will be left will now be 12 minus what is going to react, which is 9.33 recurring.
Yeah.
This here is 2.7 grams.
Yeah.
Okay.
Yeah.
We've gone about it 2 ways. Which method was more intuitive for you?
I think the first one.
The first one, good. And this one only really applies if you have been given grams. Okay, yeah. Masses. Also applies if you've been given volumes.
Yeah.
Also works if given volumes. Okay, so not to worry. The whole point of this session is to make sure you see lots and lots of variety of limiting reactant questions. I might ignore this one for, actually, why not? Just do this one. It's all revision. There's nothing wrong, no harm in you. So this is not directly linked to limiting reagents. This is just more to do with concentrations and such. So have a go at this one, and then we'll move on more to the stuff on limiting reagents.
Is it 8.75?
You're absolutely spot on. Well done. Good. No problems there. Good.
Would it be the hydrogen?
Not quite.
Uh, would it,
And I'll put an extension here, just very similar.
would I find the
How
moles
much
first?
of the excess reactant is left at the end of the reaction? Okay, so first things first, have you got a balanced chemical equation? That's the first thing you do first, because everything is hinged on that.
Sure.
Okay, so what have you got for that equation?
Is it the same as the last
Absolutely.
question?
Absolutely. It's no different, yes? And this one here, Rahil, you have to know, because what process does this represent?
Is it the Haber process?
Correct, and it's a reversible reaction. But in this process, we'll just give it one direction. So worth remembering this equation, okay?
Yeah.
Sorry, 2NH3, I don't know why I put 3. 2NH3 and 3H2, good. Now that you've got this, you can answer the question. Yeah, go on.
Would the limited with the oh wait would I've got the
Mhm.
I've got the Oh wait.
Take your time.
Would the nitrogen be
Correct.
the limiting reactant?
Correct. N2 is limiting. Very good. Now, how much of the excess reactant is left at the end of the reaction?
Actually, I'm not sure if how I've done this is right because to find the limiting reactant, because I've got the moles as 1 and 12.5,
Okay.
but then if I do the ratio and I divide that it, oh wait, so with the ratio I did the 12.5 divided by 3.
Okay, you did 12.5 divided by 3. Why did you decide to do 12.5 divided by 3?
To see what to do to the
Okay, oh, this is when you were looking at your ratios. I see, I
yeah.
see, I see. Okay, 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 okay. I see. So you've divided that by 3 there. So were you using ratio of moles or were you using ratio of masses?
Moles.
Okay, you're using ratio of moles. That's fine. That's absolutely fine to use ratio of moles. So the ratio is 1 to 3 to 2.
Yeah.
Again, like before, we're not really bothered about this here. It's this 2 ratios we're involved with. And we can pick any now. We can either pick to see, we can either use the mass of nitrogen or the mass of hydrogen, but we need to pick one and stick to it and then compare it.
Yeah.
That's the name of the game here, right? So which one do you want to pick? Hydrogen, or do you want to work with the mass of hydrogen, or do you want to work with the mass of nitrogen? Pick one.
Hydrogen.
Okay, that's fine. So what we're going to say is we're going to work out how many moles of hydrogen does 25 grams actually represent. So to find the number of moles, it's mass over molar mass. The mass is 25. The molar mass of hydrogen is 2 because it's H2 and each one is 1. So we get 12.5. Very good. So now my new ratio here is saying I have 12.5 moles of hydrogen. Based off this ratio, well, what did I do to get from 3 to 12.5? I can say 12.5 divided by 3. It's not a very good number.
Divided
Sorry?
by do you divide it by 4.16 to get
Okay. So yeah, or in other words, to go from here to there,
oh
this was times
yes,
by 4.6 or something?
16.
4.16, thank you. This was times by 4.16. So to get to the number of nitrogen moles I need to do the same operation. I need to times by 4.1. So I
Okay.
4.16 moles of nitrogen. Now I take this number here and compare it to what I actually have. If I have more than this, it means this nitrogen is in excess.
Yeah.
If I have less than this, it means it is limiting.
Yeah.
Now I use the actual amount. So what is 28 divided by the molar mass of N2? It's also 28. Yeah. So what does that give me? Times 2. So that gives me 1 more.
Yeah.
Yeah. Hang on, hang on, hang on, hang on, hang on, hang on. Have we done the right thing here? We seem to have gotten ourselves lost here a little bit. What have we just done here? That shouldn't be, hang on. So found 3 moles, 1, 2, 3. Found the number of moles, 25 by 12.5 and divided by, yeah, no, you're absolutely right, 4.16. So I'm saying I need 4.16 moles. Yeah, but yeah, absolutely. We've done the right thing. I was just checking the numbers. So if we do 28 divided by 28, we find that we've only got 1 mole of N2 in 28 grams.
Yeah.
Does that make sense?
Yeah.
But what we actually need is what? We need 4.16 based off the number of moles of hydrogen we actually have.
Yeah.
So we've reached the right conclusion. Nitrogen is a limiting factor.
Yeah.
So if this is limiting, then if it is limiting, this is another key point. You need to use the limiting reagent's number of moles to calculate how much of the stuff that is in excess will actually react.
Yeah.
I repeat, we use the limiting number of moles to work out how much of the excess stuff will actually participate in the reaction. So I now forget about this 4.1. Completely forget about it because this is not what I have. What I actually have is 1 mole of nitrogen.
Yeah.
This stuff is going to be all used up. When 1 mole of hydrogen reacts, we know that it needs 3 moles of hydrogen to react. 3 moles of hydrogen. Yeah. Now, based off this here, by the way, I should have said how much of the excess reactant in mass and moles, because it's a very vague question here. Okay, right. So 1 mole is going to react with 3 moles. So how am I going to then work out the mass of 3 moles? Yes, well, the mass of 3 moles, mass is given by number of moles times molar mass. 3 moles are going to react with 1 mole of nitrogen. So I get 3 times 2, which is 6 grams. Only 6 grams of hydrogen will react.
Yeah.
And this is in excess. So how much will be left at the end? Well,
6.5.
because I started off
Oh,
with,
oh yeah. I thought it was at 12.5.
yeah. So
Yeah.
25 minus 6, I have 19 grams of H2. I could have also worked it again, just using masses. If I used masses, I would have said 28 grams of nitrogen requires 6 grams of hydrogen to form, or 28 plus 6 is 34, but I can also check that because mass is conserved. Yeah, I can also check this 3 plus 14 is 17. 17 times 2 is 34. It checks out. Excellent. So 28 grams requires 6 grams of hydrogen. Now I can ask myself here, if I have got 28 grams, sorry, yeah, this ratio is telling me 28 grams of nitrogen needs 6 grams of hydrogen to form 34 grams of ammonia. Now I've already got 28 grams of nitrogen. But look, I've got 25 grams of hydrogen. So how much of this 25 grams of hydrogen is going to react? Well, only 6 is going to react because according to the masses in this formula, 28 grams needs 6 grams. And I've got more well in excess over 6 grams. I've got 25 grams. So 25 minus 6 gives me 19. That's another way you can do it. Is it making sense a little bit?
Yeah.
Good. It takes a while. It is a very tricky concept, but you're doing well. Now, take your time with this one. I want you to take me through the steps. This is maybe slightly a bit more challenging on the side of things that equations have not been given to you. So you are going to have to write the correct equations. So what is this thing here? Can you remember what this thing is here?
Is it? I'm not sure.
Okay, so this here is an organic compound. I'll start off with giving you that hint.
Oh yeah, it's propane.
Well done. It's an alkane. Excellent. Okay. And we're assuming that this here is the complete combustion.
Yeah.
We're assuming it's a complete combustion. Okay, so
Yeah.
have a go now at trying to work that one out. And likewise, like before, I want to add on the addition water mass of the excess reactant is left over.
Is the product of complete combustion carbon dioxide and water?
Always, okay? So remember that for complete combustion, it's always carbon dioxide and water. Very good.
So maybe C3H8 plus, is it 5O2?
Got C3H8 plus
Is it 5O2?
5O2 gives
3CO2,
3CO2 plus
4H2O.
4H2O. Okay, good. Now we are ready to rumble. I'm gonna have to give you some values here. So oxygen molar mass is 16, and this is just for the atom, by the way. Yeah, carbon Molar mass is 12. Hydrogen molar mass is 1. Yeah, so I should have given you those, Rahil.
Yeah. So I've got the moles. So.
Oh, good, 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 good.
So then. Oh yeah. So. So I've got.
Good. Which one
I
is
think
different?
I think I've got there, but like, I'm not sure how to. I'm not sure which one is the limiting one. I
Okay.
think I've got the working, but
Okay, just not too sure how to interpret your results, yeah?
yeah. Uh,
Let's look at it together and hopefully you're going to make the discovery yourself. Okay, so I'm just going to lead you and see what logical paths you decide to take in answering those questions.
Yeah.
Blank page after current. Okay. All right, here we go. So well done. You got the correct balanced equation, yeah?
Yeah.
Now, we've been given grams here. So if we don't want to work in moles, we can work in grams. but we're going to have to take the total mass of each of these things, including the numbers at the front, because we're not working in moles now. If it was just moles, we would say if it was ratio of moles, it'd be 1 to 5 to 3 to 4. Yeah. And we generally wouldn't be involved with these because these are products. Okay. But if we don't want to work in moles and we want to work in mass, I can see here, well, what's the molar mass of this? Yeah, this would be 12 times 3 plus 8. So this would be 44.
Yeah.
What would be the mass of this now? Well, it would be 5 times, well, this is 16 times 2, which would be 32. Yeah, and what would be 32 times 5?
160.
1. Correct. Okay, I'll stop here. I'm not too bothered about these. So the ratio of masses is 44 to 160. I pick one. Now tell me which one you're going to pick. It doesn't matter, but I'm now going to pick an actual mass and say, how do these compare? Which one are you going to pick?
Which one's oxygen?
Yeah, okay. You've decided to pick the big number. That's fine. Doesn't matter which one you pick. It really, really doesn't matter. So if I have 45 grams of oxygen, by the way, remember this here is pointing to the C3H8. This is pointing to the oxygen mass. So I'm saying 44, or rather, let's just say 160 grams of O2 needs 44 grams of propane.
Yeah.
Therefore, because it's this I've decided to stick to, I'm going to find a number and then compare it to what I actually have. That's what we do. You pick one, yeah, of the two reactants. So now I'm saying, how much will 45 grams of O2 need? Well, I don't know, but I'll need a certain number of grams of C3H8 to go with 45. Yes, I can now use the mathematical trick of cross multiplying. If you wish, you can think about it that way. I have 160 times x, which I wish to find, is equal to 44 times 45. Therefore, my x, I divide by 160, and I divide by 160 on this side, 11, 40, 10. Oop, no, can't go in there, can we? 8, oops, 8, 9, 9 times 11, 99 over 8, which would be 1, what is it? 91932. Yeah, 16 and 3/8. 12 and 3/8 grams. Yeah, is that what you get? I'm not using a calculator here, of C3H8.
Yeah.
So it's 12 and a bit.
Yeah.
Now I'm going to ask myself, hang on, so this is what I need to completely use up this amount of oxygen. Do I have more or do I have less of this? If I have less, it means that this thing, the other reactant, not the one I use, not the oxygen, it means that the propane is in short supply.
Okay, so
Do you understand? It's where students get stuck. It is at this comparison here. When you get stuck, lots of students get stuck because they stop here. But what they haven't done is they haven't put yourself through a talking process almost to say, what am I actually finding and why am I finding it? The why am I finding it is very important. So the reason why we were working out the amount of propane here, or why we used this given amount of oxygen to work out the amount of propane needed, because what we're calculating here is the theoretical value. The theoretical value that is needed.
Yeah.
And we're comparing the theoretical value to the actual value of what we have.
Yeah. So
if actual value is less than the theoretical value, it means that thing is limiting. If it is gone.
for the moles in for propane, that the actual one I got is 0.63, but the theoretical I got was 0.05625.
0.56. So this was
Uh,
theoretical, yeah?
0.05625.
Sorry, I missed that, Raheel.
0.056.
0.056.
Yeah.
So this was the theoretical.
Yeah.
And then the actual was 0.63.
Yeah.
Good. So this is the actual. So now again, compare these two numbers. Is the actual bigger than the theoretical?
Yeah. So
Very good.
is that in excess?
Very good.
Oh, okay.
Very good. And it's the same, and we've reached the same conclusion by comparing the theoretical value of mass to the actual mass again. And the actual is bigger than the theoretical.
Yeah.
So that must be in excess.
Okay. So it's a propane in excess, and
Yeah, the question is asking for the limiting. Yeah, so you'd have to answer it in terms of the limiting. So what would the limiting be?
oxygen.
Very good. Now, can you tell me what mass of propane will be left at the end of the reaction?
So So will I do 0.056 times 44 first?
So 0.056 times 34?
Yeah, 44.
Correct.
And then so that's 2.475. And then so will I take that away from 45?
Not 45. So remember this here, if you have
Oh no, that one's
this will be used up. There'll be nothing left. If it's limited, there'll be none of it left.
so do I take that away from 28?
It has to be taken from 28. Yeah.
Uh, 25.525.
Ooh, we've just gone wrong somewhere then. We've just gone wrong a little bit somewhere.
Oh
Okay.
wait, was I supposed to do find the
So you need to work out the mass that will actually react. So you can
I
use
need to find out the mass of the oxygen first and then take that away from 28, didn't I?
no, you don't take the mass of the oxygen from 28 because
So,
they're two separate. This is just the mass of oxygen. So all the
no, I mean like the mass of from the 0 point from the moles that I just did, like, because I thought it was from the limiting reactant.
Oh, I see what you're saying. So you're saying take away the theoretical value of moles from the number of moles of oxygen.
I'm
Trying to do.
I thought you're supposed to take away
Just
the
like
limiting.
I know exactly what you're saying, Raheel. We're going back to what we did at the very first way. If you're working in moles, you say, what is the total number of moles I have at the start? And then take away the number of moles that have reacted.
Yeah.
And then using what is left over, you then multiply those number of moles by the relative or the molecular mass, which is what we did here. This is what you mean. Yeah?
Yeah.
This
So
is what I've got in total, but what will only react will be a third. So if I take those away, I know how many moles are left, then I can multiply the number of moles by the molar mass to get the mass, the actual mass that's left.
yeah.
So you're mixing two reagents from the sound of what you were telling me. You're subtracting. So this 1/3 was subtracted from 3/7 because this is the amount of nitrogen that will react in moles. These are the number of moles we actually have in 12 grams of hydrogen.
uh,
You're following?
I I thought that we're supposed to take away the 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 limiting reactant from.
It's not the limiting reactant you're taking away. It's not the limiting reactant. So you're using the limiting reactant to work out the number of moles of the other reagent that are going to react.
Yeah.
Because the limiting reactant is going to be used up. There'll be none of it left.
Yeah. So if you took that away from the excess reactant, wouldn't you find out how much of the excess didn't react?
No, no, because the ratios are completely different.
Oh, okay.
You can't take one ratio from another by subtraction. You need
Okay.
to use, so this I'm saying, this 1/3 here, the way we've obtained this 1/3, we've used the limiting reagent to let us know that based off this amount of hydrogen that's present, only a third of the moles of nitrogen are going to react.
Yeah. So
This 12 grams is representing the number of hydrogen moles I actually have.
yeah.
So I didn't use the third because if you're actually looking here, the ratio here is 1, that's a third, and this here would be 2/3. That's the actual ratio we had here. So I'm not taking a 1 from this. They're not linked, so to speak. I'm only using the limiting reagent to work out the number of moles of nitrogen. So this 1/3 corresponds to the nitrogen. That's what's been taken off,
Yeah.
not to the limiting reagent. But I
Yeah.
used the limiting reagent to calculate this third using ratios.
Yeah.
Yeah, really tricky, Raheel, really, really tricky. There are a few more questions in there. What I would advise is watch the video. Yes, try the questions out because you're going to get these questions sent and I'll send a few more to you. Okay, rewind it if you need to, just so that you absorb it in your own time and don't feel rushed. And that's the beauty of a video. You can literally go back, rewind, and actually go, hang on, what was said there? What was actually meant? So you can play it at a much better pace than maybe the pace we've moved at. But you will get there. It's just you're not the only one. I'll tell you that students get confused. They kind of get caught in some kind of knot once it comes to comparing theoretical values and then actually going, hang on, what am I actually comparing here? What with what? Okay. So I absolutely understand. All right. But you are doing what's right. You are asking questions and you're vocalizing. So then at least I'm able to know what your thought process is so that I can guide you correctly. Okay,
Yeah.
right. So there are a few more questions in there. Take your time. I think we probably need to spend another half an hour on it, if I could be very honest with you.
Yeah.
Yeah, I'm not entirely convinced that you are exactly in the place where you should be with it.
Yeah.
So it's up to you whether you want it to be done in the next lesson or whether you want it to be done after we've done another lesson on some other topic. It's really up to you. What do you prefer?
Can we do I can't remember what was can we do biology next lesson?
Yes, biology. Yeah, correct. Any particular topics that you want to focus on?
There was something I wanted to do. I can't remember what it was now.
Okay. Do you want to have a look at your
Yeah.
notes and then text me?
Yeah. I'll message you.
Yeah, that would be great. Next lesson, what for?
Could you do um could you do Sunday?
Sunday. I will try Sundays just because of the Easter holiday coming up.
Oh
family wise, there's a few things coming up, but I'll
Yeah.
try and if I can't do Sunday, would you be flexible to do Monday?
Yeah, that's fine.
Okay, cool. All right. I'll put some provisional times here then. So either Sunday afternoon. Okay, so these are just provisional times.
Yeah.
Okay, Sunday afternoon / Monday afternoon. Is that okay?
Yeah, that's fine.
I'll confirm with you. Well, send me the topics. When you send me the topics, I'll use that time to confirm with you which of these days I'm most likely to be able to do.
Yeah.
Is that cool?
Yeah, that's fine.
Brilliant, Raheel. Nice one, nice one. But you've got enough time now because we're not seeing each other for a while. Take time. You don't need to listen to the whole video at one time. Just look at the problems almost with a fresh eye and say, okay, if I had to do this, how do I go about it? Just try and go through the problems as well. If you can't, rewind and say, okay, how did we actually do it? And then look at the process. And hopefully then when we do meet, when we do chemistry again, you'll find that it's not as bad as it looks. All right.
Yeah.
Super. All right.
Yeah.
Have a lovely rest of the day, and I
You
shall see
too.
you either Sunday or Monday.
Yeah, thank you.
All right. Most welcome, Real. Cheers. Bye now.
Bye.
Bye.